Now let's look at some of the string methods. How do we know? How do we find all the string methods? Well, we can use dir. So print dir str, and that's going to list all the string methods. The most important ones are these ones, the one without the underscore towards the end, which are these ones right here. So some of them are like, let's say this is capitalize, case fold, center, count, encode, ends with, expand tab, all these ones. So let's look at few of them. We're not going to look at all of them, but we look at the few important ones. If you want to know what these things they do, you can actually even type print help str. That's going to give you a short summary, a short like a documentation on what each one of them does. So let's just go down. Let's look at one of them. Let's look at this one, encode. It tells you this encodes the string with the codec registered for encoding. Count. What it does, it returns the number of non-overlapping occurrences of a substring. So basically, this is a documentation that allows you to see or allows you to understand what these functions they do. That's what this help is all about. Okay, let's run this. All right. So let's say you have a string like this. This is your text string. I'm printing the text, and I also want to know what is the size, how many characters are in my string right here. So in this case, when I run this, it prints out 17. There are 17 of them. That's what this function length does. Let's say you want to convert everything into a lowercase. So suppose this is my string right here. Okay, let me just comment everything out so you can see what's happening. So in this case, I'm printing the text. I'm also printing a text dot lower. What this is going to do is going to turn every character in this into a lowercase. And when I run this, it's going to print out this string right here. Python is a cool language. It is not a snake. That would be this print statement. And the next print statement lowers everything down. You can see that the word cool has been lowered and the word not also has been lowered. What about upper? Well, if you guess that's going to convert into uppercase, you would be absolutely right. So if I run this, it prints everything into uppercase right here. What about count? Well, most of these words they are very intuitive. So count will basically count how many that characters are there, how many O's are there. When I run this, it's going to print three O's are there. You can actually count. You have this O right here, then you have this O, and I think yeah, there's another O, three O's. So that's why it prints out three O's. It did not count this capital O and it did not count this capital O because it is case sensitive. How about if you want to find the index of this word is, you can do that too. In this case, it prints out the index 9. So the index is is present, sorry, the word is is present at index 9. You can actually count index 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, sorry, let's come over here. Okay, now what if you want to count how many O's are there regardless of the uppercase or lowercase? So what you do, you convert your text into lower, first thing, and step number two, then you count your O. So this is called chaining. And this allows you to count the total number of O's in this case. So there'll be 5. Again, the first step is going to convert the whole text into lowercase. And once I convert into lowercase, then I count my O, and this gives you 5. What if you want to remove a certain characters? So there is a function called replace. And what replace does is going to replace one sequence of characters or a string with another string. So let's say I want to replace py with my, and this is my text right here. So in this case, when I run this, it's going to replace py, which will be this string. Okay, and let's see, this string right here. It's going to replace all py with my. You can see that it printed my and it printed my over here. What about, let's see, can you chain replace? Yes, you can. So for example, let's say you have a text like this, ML at the rate of 2025, exclamation, exclamation. And you want to remove these types of characters. Okay, maybe you want to clean up your text. So you can use replace to clean up the text. So in this case, I'm saying text dot replace at the rate with empty string. Also replace exclamation sign with empty string. In other words, I'm chaining. Okay. Now when I run this, it cleans up, it prints out my cleaned text right here. This right here, which is it has removed all these unnecessary characters. Then there is an inbuilt method called starts with that returns a boolean value if something starts with with a certain substring. So let's say this is my text over here. I want to check if this text does it start with the word machine. Let's run this, and if the answer is true, it does. It prints out true. What about this? Text, does it starts with learning? Is this true? Well, in this case, it's false because this text does not start with the word learning. What if I change this to lowercase? And if you guess that's going to print false, you would be right because Python is case sensitive. What about ends with? Just like there, just starts with, ends with. Ends with actually returns true or false depending on if the text ends with a certain substring. So in this case, let's say I have a file name, marble.pkl, pickle file, and I want to know, is this file pickle? So file name dot ends with dot pkl. So in this case, it's going to return true because this particular file name, this particular text, it has dot pkl. It ends with dot pkl. On the other hand, it does not end with dot csv. That is why it returns false over here. We can also check for substring using in operator. Very handy and very optimized. This is optimized because it is using C in the background. So suppose you have a sentence like this, and you want to find a word try in it. Well, one way you can do is just manually go through each one of them. That's going to take you forever. What if this sentence is like hundreds of thousands of lines of long code, of thousands of lines of text characters? How would you find that? Well, you can use this in operator. So in this case, I'm saying b equal to try in sentence. In other words, try to find this word try. And when I run this, it prints out true. That means this try is present in there. And you can look through there over here. You will find the try somewhere over here. Oh, there it is. Try. What about the word rain? Is the word rain present in your sentence in here? Well, in this case, it prints out false. It is not present. You can go through each one of the words over there, and you are not going to find the word or the substring rain in there. Uh, Now, let's look at lstrip, rstrip, and strip functions. Suppose I have a string like this, and there are some empty spaces over here in the beginning and at the end over here. How can we get rid of that? Well, you can actually use these functions, lstrip, rightstrip, or strip. Lstrip, what it does, it removes the empty spaces from the left hand side. So when I run this, it's going to print your text, which is this right here. This is my original text, and I'm removing all the empty space in the beginning, which is this part right here. It removed the empty space, and this is how your string appears now. What if you want to remove the empty space towards the right hand side? In other words, this one right here. Well, for that there's a rstrip function. If you run this, this removes this empty space over here. What if you want to remove both of them, left and right? So there is a just strip function. Strip is gonna remove both left and right, and as you can see, this side is also gone. And although you're not able to see, but this side is gone too. Then there's a title. Title is for making every word uppercase. If I run this, you can see that your P becomes capital, your I becomes capital, your C becomes capital. Every single word, every single character of the first word, it becomes capitalized. That's what your title does. Then you have split. A lot of times you come across data where it is delimited by some separators. In this case, let's say this is your data right here, and each value is separated by comma, and you want to separate this. So how would you do that? Well, there is a split function. And what split does is going to take this string and you're going to split that based on this comma right here. So I'm specifying the split based on that. So I run this and it splits this thing. And when it returns something, it returns in the form of a list. So now you can see your 2025 08 23. That would be your first element of your string, of your container, of your list. This comma, and then Ashwani. Then it prints out Ashwani, comma 34, 34, comma triple zero, triple zero. Oops, sorry. Uh, Triple zero. Then 34.78, 34.78. Okay, what if you don't want the comma as a delimiter, or maybe there is a word comma in there because it's a currency. Maybe this number is supposed to be 34,000. Okay, maybe you don't want the comma to be used as a splitting factor. Maybe you want to use something else, maybe semicolon. You can do that too. So in this case, I'm using semicolon. So when I run this, it's going to split based on the semicolon. It's going to print this as your first element of your list. This is your second element of your list, and this right here is your third element of a list right here. And this would be your fourth element because now it's using semicolon, which is this right here, as your splitting criteria. Then there is a likewise, there is the opposite of that. There's a reverse of that, which is join. And what join does is going to take a list like this, like a word list, and it's going to join every single element in it together. And it's going to create a giant string. So when I run this, it prints out 2025 0823, and it joins with this thing in between. Ashwani space this thing. I can actually put something over here. I can just put, let's say, plus 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 like this, and remove this. Now when I run this, you can see that it prints out 2025 0823, and then bunch of plus in between, Ashwani, bunch of pluses, and like this. So whatever you put inside is gonna, happily print that. If I put comma in there, run this, it's gonna put comma in every single character. So this is your join. And then you have inbuilt methods to check for text properties. For example, maybe you want to check if the text is alphabetic, or maybe you want to check if the text is digit, or maybe you want to check if the text is alphabetic and numeric by nature. So let's do each one of them. So suppose this is my s equal to hello, a string, and I want to check if this string is alphabetic. So in this case, you say s dot is alpha. When you run this, it's going to print true because this is alphabetic. What if I change this and I put an empty space in between? Let's see what it does. When I run this, it's going to print false because of the presence of this empty space. This is not an alphabetic character. What about this right here? In this case, my s is equal to 2, 3, 4, 5, 1, all numbers, but it is in a format of a string. When I run this, it prints out as a true because everything inside is a digit. Well, what if I put a space in between or some other character? Well, in this case, it's going to print false because this is not a digit. This one right here, if I run this, this is going to print true because this one has alphabets in it, also has numbers in it. On the other hand, if I put space in between, or any, it doesn't have to be space, it can be any fancy character, it's going to print false. For example, if I put plus over there, or this sign, or maybe this sign, it is going to print false too. If I run this, you can see that it prints false.